This is a distribution of wrong answers to one of Andrew's assignments. The answers happen to be pairs of numbers, so you can draw them on this two-dimensional plot. Each of the little crosses that you see is a different wrong answer. The big cross at the top left is where 2,000 students gave the exact same wrong answer. Now, if 2 students in a class of 100 give the same wrong answer, you would never notice. But when 2,000 students give the same wrong answer, it's kind of hard to miss. So Andrew and his students went in, looked at some of those assignments, understood the root cause of the misconception, and then they produced a targeted error message that would be provided to every student whose answer fell into that bucket, which means that students who made that same mistake would now get personalized feedback telling them how to fix their misconception much more effectively. So this personalization is something that one can then build by having the virtue of large numbers. Personalization is perhaps one of the biggest opportunities here as well, because it provides us with the potential of solving a 30-year-old problem. Educational researcher Benjamin Bloom in 1984 posed what's called the 2 sigma problem, which he observed by studying 3 populations. The first is the population that's studied in a lecture-based classroom. The second is a population of students that studied using a standard lecture-based classroom, but with a mastery-based approach, so that students couldn't move on to the next topic before demonstrating mastery of the previous one. And finally, there was a population of students that were taught in a one-on-one instruction using a tutor. The mastery-based population is a full standard deviation, or sigma, in achievement scores better than the standard lecture-based class. And the individual tutoring gives you 2 sigma improvement in performance. To understand what that means, let's look at the lecture-based classroom, and let's pick the median performance as a threshold. So in the lecture-based class, half the students are above that level and half are below. In the individual tutoring instruction, 98% of the students are going to be above that threshold. Imagine if we could teach so that 98% of our students would be above average. Hence, the 2 sigma problem. Because we cannot afford, as a society, to provide every student with an individual human tutor. But maybe we can afford to provide each student with a computer or a smartphone. So the question is, how can we use technology to push from the left side of the graph, from the blue curve, to the right side with the green curve? Mastery is easy to achieve using a computer, because a computer doesn't get tired of showing you the same video 5 times. And it doesn't even get tired of grading the same work multiple times. We've seen that in many of the examples that I've shown you. And even personalization is something that we're starting to see the beginnings of, whether it's via the personalized trajectory through the curriculum or some of the personalized feedback that we've shown you. So the goal here is to try and push and see how far we can get towards the green curve. So if this is so great, are universities now obsolete? Well, Mark Twain certainly thought so. He said that college is a place where a professor's lecture notes go straight to a student's lecture notes without passing through the brains of either. I beg to differ with Mark Twain, though. I think what he was complaining about is not universities, but rather the lecture-based format that so many universities spend so much time on. So let's go back even further to Plutarch, who said that the mind is not a vessel that needs filling, but wood that needs igniting. And maybe we should spend less time at universities filling our students' minds with content by lecturing at them, and more time igniting their creativity, their imagination, and their problem-solving skills by actually talking with them. So how do we do that? We do that by doing active learning in the classroom. So there's been many studies, including this one, that show that if you use active learning, interacting with your students in the classroom, performance improves on every single metric, on attendance, on engagement, and on learning as measured by a standardized test. You can see, for example, that the achievement score almost doubles in this particular experiment. So maybe this is how we should spend our time at universities.